Okay, this is a brief lecture for Unit 18 to be covered on next Thursday, November 7th. I'm recording it ahead of time because, as you know, I'm out of town. You should listen to this lecture and then take the quiz over Units 16 through 18. And also respond to this discussion online for your attendance. Unit 18 is about poured-in-place concrete floor systems. From this unit, you should be able to distinguish between ground-supported and suspended floor systems. You should be able to define and recognize one-way solid slab and beam floor systems, one-way ribbed or joist slab floor systems, two-way slab beam floor systems, and two-way flat plate floor systems and waffle slab floor systems. You should also be able to prepare and know the difference between engineering drawings for poured-in-place concrete floor systems and placing drawings. So what is a poured-in-place concrete floor system? One-way solid slab and beam, one-way ribbed or joist, two-way solid slab and beam, or two-way flat plate and waffle slabs are the different types. And you can see examples of these in your text. Here on this slide we have a one-way solid slab system. You can see that there are columns supporting it. Then we have girders, which are the deeper beams resting on the columns. Then we have beams, which are shallower than the girders, resting on the girders. And then the slab spans between the beams. So this is one way because the reinforcing in the slab will tend to run in one direction from beam to beam rather than in both directions. So that's a one-way slab and beam system. Here you can see an example, a cutaway plan view showing the columns, then the girder, then the beams. Then this is a picture showing through the concrete of the reinforcing. See how it's running one way, and there's heavier reinforcing over the actual beams. So the other type is a one-way concrete joist or rib slab. Here again we have columns, and then beams span between the columns. In this case, these are the beams. There are no girders. And then joists span from beam to beam. So these would be the joist or the ribs. The slab then spans between the joist. So this is more of a modular prefabricated form system, and it keeps it economical. Then here's a picture of a one-way concrete joist rib slab, and you can see the formwork creating the ribs. In a one-way joist system, the bottom of the beams and the joist are all in the same plane, simplifying the formwork and construction. If you go back to this, you can see what they mean. All of this, there's nothing deeper than anything else. So it simplifies the formwork and the construction. Simple level surface is formed on site, and next prefabricated metal or fiberglass joist pans are placed on this surface to form the system of the beams and the ribs. Then you have a wide module concrete joist system, like the one-way joist, but the ribs are spaced further apart, 4 to 6 feet rather than 20 to 30 inches. Here, a thicker slab is required to span the greater distance between the ribs. And you might need that, as it says here, for fire resistance. It's also called a skip joist because, as in the other one, there was a joist in the middle of all these, if you go back. And here it's like you skip a joist. Da-da, okay. So then we get into the two-way floor and roof framing systems. And as the name implies, that means the reinforcing will go both ways. Two-way framing systems structurally go in both directions. Typically, they work better with more of a square bay You can get up to 2 times the length and have a rectangular, but after that it's really not economical. They're more structurally efficient than one-way slabs of the same thickness. Two-way slabs must span roughly the same distance in both directions. As the layout of the slab supports become increasingly rectangular, and the proportion of the efficiency of the two-way slab decreases. So this is not near as efficient in a two-way system as this is. Here's an example of a two-way solid slab. So you have the columns, and then you got a system of beams resting on the columns, and then you have the slab on top of that. This is very suitable for heavy loads. For instance, parking garages use this system a lot. Two-way flat slab is a two-way reinforcing slab supported only by the columns. There is no beams, as you can see here. Sometimes the columns do have mushroom capitals or conical capitals. And then there's little drop panels, a little thickening of the slab there, but still there is no beam. This would obviously carry a heavier load than that. Here's an example of the reinforcing in the slab. You can see the columns, then you've got the thickened plate, and then you've got the two-way reinforcing. And the reinforcing creates sort of a beam between the columns there. It's just within the slab though, and then the reinforcing thins out in the middle of the bay. Here's an example in a parking garage. You can see the drop panels, but there's no column capitals. Here's a two-way flat plate. Like the flat slab, the two-way reinforced slab is supported only by columns with no beams. There are no column capitals or drop panels in the flat plate system. Additional reinforcing with the depth of the slab at the column, additional reinforcing within the depth of the slab at the column slab junction is used to increase the strength in that area. These are best used for lighter loads than the other type. You wouldn't use this in a parking garage. You might use it in an apartment or a condo or a hotel type thing where the loads aren't quite as heavy. Here they're putting the reinforcing in for the two-way flat plate system. You can see well, these orange things are the shear studs, and that's in the concrete, and that adds shear resistance. Then the green cables are post-tensioning strands, and what that is, they pull those after the concrete's poured. They pull them really tight, and once the concrete's cured, they let them go, and it kind of all springs in, and it makes a very stiff structure. Here you can see a two-way flat system being used in this, probably an apartment building or motel, hotel type system. Here's a good view of it. You can see how thin it is. So it reduces the floor-to-floor space. You probably still would have a drop ceiling for your AC and stuff like that, but it minimizes the height. And thus, also the construction cost. Then next we have the waffle slab system. Looks like a waffle, that's why it has the name. It's similar to the one-way joist system, but with a two-way system of ribs. So basically it's the ribs going both ways. Constructed with prefabricated domes that simplify the formwork in construction. Around the columns, domes are filled solid to create heads. So this would be a thickened area, like any other situation, increasing the strength around the columns. Here you see a two-way waffle slab system in a garage, and then these are filled in, and these columns even have a conical top. Okay, so that's the end of my slides. So back in Unit 18, pretty much that's all covered in here. Your assignment is to do reinforcement activity number 2 on page 264, and it says to redraw the engineering drawing in figure 18.8 with the following changes. And figure 18.8 is on page 261. The changes are you increase the 12-foot dimensions to 15, so you can see the distance between the columns A, B, C, and D are all 12 feet. You need to increase that to 15 and scale it accordingly. And then you increase the 10-foot dimensions to 12. So between columns 1, 2, and 3, where it's 10 foot, you're going to make that 12 feet. And then all the columns will be 12-inch square columns using number 5 rebar. So you need to draw and note that accordingly. So your drawing will look very similar to that on page 261 with the difference in the dimensions and the notes. And that would be an engineering drawing, typically with a little less detail. For comparison's sake, I'm not making you draw this one, but the placing drawing is on the next page, figure 18.19. And here there's much more information about the rebar, the bending, and how much there is, so that this is what they actually build it from and order the steel. So that's it for unit 18. And then just for your information, when we meet again on November 12th, we will review unit 19, and we're planning on having our second exam over units 11 through 19 on Thursday, November 14th. Again, please respond to this discussion for your attendance grade, and you should watch this on Thursday, of course, because that's when our normal class time is. Any response after Thursday will not count towards attendance. Thanks. Talk to you later.